engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
Questions. Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to the show where we bring you the latest breakthroughs in science, technology and medicine with me, Chris Smith, and with Eva Higginbotham.
Coming up, government plans to vaccinate children against COVID-19, why quantum physics just got even weirder, and artificial intelligence that predicts when mums will go into labour.
Plus, fermented foods. Is this a tasty health myth, or is it rooted in reality? We're delving into the science, including finding out how your favourite cheeses get made and knocking up some sauerkraut.
The Naked Scientists podcast is powered by ukfast.co.uk.
As levels of coronavirus infection continue to fall here in the UK and the number of people vaccinated continues to climb, the government announced this week they're now considering widening the scope of the vaccine programme to include children aged 12 and up. The aim is to try to head off an autumnal surge in COVID cases when the schools go back in September. And a similar strategy is playing out in the US. And Chris caught up with University of Wisconsin-Madison paediatrician and vaccine specialist James Conway to consider this and the wider issues concerning the vaccine programme.
Current data that's been emerging as each company has moved into the younger and younger groups shows that these vaccines are very protective. And I don't think that's any surprise. I think we've seen that they're quite protective in older individuals as well. And so we anticipate in kids, where the immune system is even that much more robust, that they're going to have even a better and more protective response than the older individuals.
Why do you think then that when they were doing the trials that they didn't include children? I mean, is that a standard approach when developing a new medicine? We just don't test medicines on kids?
Well, in general, that's true, although I think that each disease has a particular age focus. I mean, if you think about many of the other routine pediatric vaccines that we use for children, many of those are diseases that actually primarily affect kids. And so by definition, then the trials have to start out in those age groups. For this particular disease with COVID-19, obviously the primary groups were the elderly and then people with comorbidities. And so all of the companies appropriately were directed to really put their attention and their efforts into those groups first. In the beginning, we thought that kids were, relatively spared, but I think that was partially because we were so successful at protecting them by bubbling and keeping them out of school and things. Now that people are starting to loosen up activities, we're starting to recognize that kids actually can be transmitters and can even be drivers of outbreaks.
Critically, though, they are at really, really low risk from severe coronavirus manifestations, aren't they? One of our deputy chief medical officers quite famously last year said, quite frankly, a child is at greater risk from being run over by the school bus than they are from a dose of coronavirus infection. But what that means is that some parents have turned this round and they're saying, well, given the low risk to children from disease, the vaccine actually, albeit with rare side effects, potentially poses a greater threat than the disease does.
Well, I think that represents something of a false narrative. I mean, low risk doesn't mean no risk. And so, there have been hundreds of children who have died unnecessarily from this disease. And we recognize that every life is valuable. And so I think there is a major moral imperative to try to protect all individuals that could suffer from this disease. But the secondary gain then is also that public health measure of then starting to be able to eradicate ongoing circulation by achieving higher and higher rates of community immunity, or what some people call herd immunity.
And is that the approach being taken in the US as well?
Yeah, the approach here in the US was initially to do individuals over age 65 and then healthcare workers, then moving into younger populations, and then more recently now moving into high school aged and then eventually middle school aged children. Within the next few weeks, we think there will be approval of vaccines into those populations.
Looking just kind of across the world now with your sort of global vaccine hat on, how do you see all this playing out? Because what is hitting the headlines a lot at the moment is the question of what rich countries are doing versus what poorer countries are doing.
We will never eradicate any disease without reaching every child and reaching every corner of the world. And so I think it has been a little bit of a blind spot for many of the richer countries to focus internally, which granted from a political standpoint is what their pressure is going to be, but that we'll never be able to get back to any degree of normalcy with global trade and global travel until we also start to stamp out circulation around the globe. And so I think that there really has to be and is finally starting to be a lot more attention on a collaborative approach to try to make both funds and vaccines available. But the other piece though is that vaccine hesitancy is real. There's certainly been a lot of tension around certain countries being more willing and eager to vaccinate and how those vaccines get distributed equitably within those countries.
Of course, that was a worry in America before all this began, wasn't it? Studies last year were suggesting that maybe as many as half of Americans would turn down a vaccine if offered it the next day. That has changed, though, because we saw a similar kind of uptick in uptake in the UK.
Yeah, it's been interesting because of the half that were sort of a little bit hesitant, we've seen a substantial number of that population shift over into being more willing. And then what we've seen is really an entrenchment of about 20% of the population who have really dug in their heels and said that for whatever reason, whether it's COVID complacency or COVID denialism, or whether it's, with other political reasoning, that there are about 20% of the people that are just flat out refusing for various reasons to be vaccinated. And so it does raise the specter of will we actually be able to get to the point of herd immunity at a high enough rate that the ongoing transmission could completely be eradicated. And so what we're starting to realize and starting to worry about is that if we see that manifest itself globally, this becomes then, like influenza and many other respiratory viruses, something that just continues to circulate in the background and serve as an ongoing threat, especially to those with underlying medical issues.
Is that not likely to be the case anyway?
Well, except that there's something of a defeatist view in that kind of mindset because, here in the United States, we only achieve about 40 to 45% of the population gets a flu vaccine in any given year. There's no mandates and really very few requirements except for some limited professions and areas of the country. And so we still deal with, hundreds of thousands of hospitalizations and, 20, 30, 40 million cases a year, lots of lost time from work and lost time from school, and, 20, 30, 40, 50,000 deaths a year in bad years. And it's been somewhat saddening to me as a public health leader to realize that people have been willing to accept that kind of defeatist mentality. We've defeated and eradicated a handful of diseases from the face of the earth, smallpox and some types of polio. And we did that by a concerted global effort to achieve high herd immunity rates across the globe. And we have that capacity. We've clearly shown historically that we can do that, but it takes a concerted, organized effort. And, the hope and the dream is that in some manner we can figure out a way to incentivize immunization so that the larger portion of the population does accept these things. And maybe we can actually get rid of ongoing circulation and outbreaks of these diseases.
Well, let's hope so. James Conway there.
When physics deals with things at the very small scale, like atoms or molecules, the familiar rules that explain how planets go round the sun or how a car accelerates down a motorway are left behind, and things start to behave in strange ways. This is the weird world of quantum mechanics, and no one knows why this happens. Even the person who helped to invent this branch of physics, Niels Bohr, famously once said, "If you're not shocked by it, you haven't understood it."
That goes for me too. Now, one of the oddest, arguably, quantum phenomena is the manifestation called entanglement. Now, this is where two separate entities act as though they are, in fact, one, even if they're separated by vast distances. As an extreme example of this, if you took two entangled atoms and you moved them to opposite sides of the universe and you did something to one of them, the other would instantly know about it. See, we told you it was very strange. But now it's just got even weirder, because a team of American physicists have leapt over the boundaries of this quantum world and they've made the same thing happen, but to much larger entities than just atoms. Durham University physicist Fran Chadder-Day wasn't involved in the research, but, as Phil Sampson found out, she was nevertheless very excited by the results.
As far as the quantum world goes, it's huge. So this really shows that quantum physics can and does apply to larger objects.
This is a quantum effect, normally on the scale of tiny particles, but they've managed to make it on the scale of many, many, many particles.
Yeah, that's exactly right. We normally think of quantum entanglement as something that affects atoms and molecules, but these researchers have achieved quantum entanglement with two objects that are about 10 trillion times bigger than an atom.
What actually is quantum entanglement then?
Quantum entanglement is an effect where when two objects interact, they can no longer be considered as two separate objects. They must be considered as one object. And this is true even if, after interacting, you move them really far apart.
That's absolutely wild, though. It sounds like you might have two halves of a locket, something like that, that are still behaving as if they're one locket.
Yeah, that is what it's like. And it's freaked people out for a long time because, people have called it spooky action at a distance because these things do seem to happen instantaneously. You can affect one object by doing something to the other.
It's incredibly spooky.
Yeah, which is why it's kind of, when it was only happening with atoms and molecules, I think people were a bit less freaked out because they're so small, they're so far removed from us. But now that it is happening with bigger and bigger objects, it's even spookier.
What are the objects that these researchers have managed to entangle?
So it's two drum heads which are made out of thin film aluminium.
As in drum heads, as in the top of just a drum?
Yeah, it's like the top of a very, very small drum.
Why have they gone for these objects, do you know?
It's because of the method they use to entangle them. They place them in a cavity, and by sending in two pulses of light, they can entangle these drum heads. So the first pulse has the effect of creating an entangled photon with the motion of the first drum head. And the second pulse has the effect of exchanging that photon with the vibration of the second drum head.
Is it like they've managed to link these two drum heads together somehow via this interaction with a tiny particle of light, a photon, and that linking together has set up this quantum entanglement state?
Yeah, that's exactly right.
How do they know that they've actually done it?
There are correlations between the position and the momentum of both drum heads. Correlations can also happen with classical physics. So they have to do some kind of maths on the positions and the momenta in order to prove that the only way the particular correlations they observe could arise is because of quantum entanglement.
Right, so classical says one thing, quantum says the other.
Yeah, that's right.
And they found that it was the quantum one and not the classical one.
Yeah, so this is a really huge result.
Could you take these two drums really far apart and they'd still be entangled and have this correlation?
Yes, in principle you could. You'd have to be a bit careful that as you move them far apart, they didn't kind of interact with other things that might destroy the entanglement. But in principle, you could.
Could they, in theory, make the drums bigger or add more drums or do that kind of thing?
Yeah, so they do say in the paper that they hope that this will be a stepping stone. So I think we should be expecting to see this research progressing even further to bigger or more objects.
Do you think it'll progress to the stage where my example of the locket that maybe I'm sharing with some long lost love actually is entangled and you can actually achieve that?
Probably not. There's going to be so many interactions with the air, with other things in the environment that would destroy entanglement.
Is this useful for anything? Or is this just a cool bit of physics that's never been seen at this scale before?
It could be useful. There's all kinds of technologies in development, like quantum computing and quantum sensors, that really rely on having this precise control and measurement of larger quantum systems.
So how's that for a quantum leap there? Member of the long-lost Lonely Hearts Club, Phil Sansom, talking to physicist Fran Chadder-Day, and she was commenting on research by Shlomi Kotler, published in the journal Science. Coming up, blood testing using thousands of chemical markers is helping researchers to predict when babies are going to be born. And
if you ferment your cabbage correctly, It can have such a wonderful flavor, and you can just add a little bit of garlic to it, maybe a tiny bit of pepper, and have a wonderful salad.
We get our teeth into the science that's fermented foods.
Since the 1950s, when it first entered the mainstream, the world has been hooked on plastic, and now we produce hundreds of millions of tons of the stuff each year. Whilst its resilience and stability make it attractive as a material, the fact that it's so long-lived and does not readily break down means it accumulates in the environment, and often this takes the form of tiny particles, called microplastics, which are formed when bigger pieces of plastic break apart.
In recent years, scientists have become increasingly alarmed about the build-up of these microplastics in the ocean, where they can concentrate chemical toxins in animals' bodies. Now a team from Iceland have found them in a new place that we hadn't expected, in glaciers. They're literally coming down in the last shower and becoming embedded in the ice, where they can change its properties. Reading University climate scientist Ella Gilbert, who wasn't involved in the study herself, took me through the new findings.
These researchers were looking for the influence of microplastics, so teeny tiny particles of plastic in ice rather than in oceans, which we typically think about, or in food chains.
Where were they looking?
So they looked in this very remote, pristine glacier in Iceland. And to do this, they were looking at snow samples that they collected in this glacier.
Why did they choose the location that they did?
Well, the idea of this is that it's extremely remote, so it's mostly untouched by human activity. It's not likely to have been contaminated by anyone traipsing up there or any tourism, anything like that. So it does give you a good indication of how environmental processes in their sort of natural, pristine state are influencing and transporting microplastics to this really remote region.
Now, when you say transporting microplastics, what did they actually measure then? What did they collect?
So they drilled down or collected kind of cores, so tubes of snow and ice from the surface, which give you an indication of what's been trapped in the snow and the rain that's fallen over the last several months. And they analysed this in the lab, and they found lots of different microplastic particulates. That indicates that those plastics came from somewhere.
Where from?
They don't know 100%, but they're pretty sure it's to do with atmospheric transport. The process that they suggest is that these plastics that have been broken down, for example, in the ocean or in river systems or something like this, that have been transported in the process of evaporation from the sea or the river, formed into clouds, transported to Iceland, and then they've fallen in the snow and rain. It shows you how connected every different element of our planet is, whether, that means that you can get plastics in the ocean breaking down and then ending up all the way almost at the poles is quite mind-boggling.
How much plastic did they find?
I couldn't actually tell you the numbers. They did find a considerable amount, and they are very small particles, but it just demonstrates the pervasive nature of these particles.
And presumably, if it's landing as snow, that snow is destined to become part of the glacier because it will pack down and join the mass of ice that's there, which means these plastic particles are going to end up lodged in the ice.
Precisely. They will become inevitably part of the glacier, and eventually will end up back in the sea again as part of the kind of natural cycle of glaciers and ice sheets and ice shelves. What's interesting and perhaps very worrying is that the placement of these particles in the glacier can actually start to influence the glacier. And that's quite an interesting insight that I hadn't personally, before I read this study, actually considered.
In what way will they change the glacier?
Because pristine ice and snow behaves in a specific way, if you add something else, say it could be rock, it could be plastic in this case, it changes the way that the ice absorbs energy, absorbs radiation from the sun, and that influences how the ice melts, it influences how the ice behaves, how it moves. And this effect on the macro scale can actually have an influence on the melting of the glacier, for example. And now that's not completely clear from this paper, it's mostly a speculation, but if it did increase the amount of melting that occurred, then that could potentially contribute to sea level rise, which of course is a worrying consequence.
And what's the take-home message, do you think? I mean, to a person who's interested in how climate works and studies it professionally like you, what do you take away from this?
The main thing that I'm taking away from this is the demonstration of how connected our planet is. It shows you how something that ends up in the ocean, which could be hundreds of thousands of miles away, and then ends up all the way at the poles accumulating in a glacier. It's not exactly what you imagine when you throw your non-reusable plastic bottle into landfill, is it?
Definitely not. Ella Gilbert, and the study she was commenting on has just come out in the journal Sustainability.
To pregnancy now, expectant mothers and fathers are, of course, understandably excited to know when their new baby's going to turn up. And there are, of course, also important clinical implications to knowing when a mother's going to go into labour, especially when you've got a higher risk pregnancy on your hands. But currently, the best we can realistically do is to estimate across about a 5-week window when the so-called due date is most likely to fall. But now researchers at Stanford University have developed a test that uses artificial intelligence and the levels of a range of chemical markers in the bloodstream to narrow down that window. And Eva asked Cambridge University obstetrician Catherine Aiken, who wasn't involved in the study herself, to take her through what the new results show.
If we could be more accurate about when a baby was going to be born, that would be a massive game changer in obstetrics. First of all, for people having completely normal pregnancies, it would just be really nice to know when to expect their baby. But for us as obstetricians looking after high-risk pregnancies, it would be amazing to be able to have a better fix on the likelihood of a preterm birth, for example, because if we know about that, then we can prepare for it, and we can also work on strategies to prevent it. It would also be really important for women who are at risk of pregnancy complications like preeclampsia or sepsis. All kinds of women would benefit immensely from better and more detailed information about when the baby would be likely to be born. It's something that has always been a massive question, not only in modern obstetric science, but even before that. There are ancient writings trying to predict times when babies are going to be born. And it's been one of those questions that you can find science on right from the very beginning of scientific writing. But you never really get all that much better at predicting it, despite all the enormous amount of studies that have been conducted in this field.
So what sort of work are people doing to try and improve our estimates?
So the kind of work that this study has done is amazing. So what the authors have done is to take blood samples from the mum over 3 different time points in the 100 days leading up to giving birth, make a model of the substances, the proteins, the enzymes, the molecules that appear in mum's blood, and look at how they change up to the time of giving birth. And so what they can effectively do is produce a profile of dynamic changes in the mother's blood as you approach labour.
So is it like a fingerprint of, well, as you get closer and closer to labour, this substance goes up, but this substance goes down, and they interact in that kind of way?
Exactly. It's like finding a signature set of changes that you expect to happen in the blood of the mother leading up to the time of delivery, with the idea that if you see that particular fingerprint, then you know that that's someone who's going to give birth sooner rather than later.
What sort of markers did they find?
So the things that they find surging before delivery really weren't a huge surprise to us. They find a massive increase in the steroid hormones circulating in mum's blood, and that's something that we've known from previous studies and also from animal models of animals going to give birth, that there's an enormous surge and a difference in the type of steroids that you produce just before delivery occurs. They also find a really interesting protein called IL-1R4, which is used in coordinating a change in immune activation and in regulating inflammatory responses. And that's really important because what we know is that pregnancy maintenance requires an immune tolerance to your baby, and then that there's an inflammatory response that seems to be dampened down by this IL-1R4, which could be really important in regulating that pre-labour phase.
With this signature, then, how narrow a window did they manage to narrow down compared to how big a window we normally have to say the baby's going to be born in here somewhere?
So the 5-week window that we have now of a normal range for the baby to be born looks like it could be narrowed by this kind of study to around 2 weeks, which would be a hugely different clinical scenario.
And how likely do you think it is that we're going to end up in a future where we can say, look, Tuesday, 2 o'clock, that's when you're going to go into labour naturally?
Oh, wow, that would be amazing. I think we're a little way from that just yet.
Still pretty impressive nonetheless, though, isn't it? That was Catherine Aiken there.
And if you'd like to find out more about any of the news stories we've discussed, the links to each of our referenced papers are on our website, www.nakedscientist.com, along with the transcripts of each interview for every Naked Scientist show.
Much has changed for business owners, managers, and staff recently. But with over 30 years' experience in telecommunications, award-winning independent company Spitfire have the expertise to make sure you stay ahead and can keep on innovating. Whether it's connectivity, MPLS networks, firewalls, or phone systems, Spitfire can help. To find out more, go to spitfire.co.uk. That's spitfire.co.uk. Spitfire, telecoms and IP engineering solutions for business since 1988.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
This is The Naked Scientist with me, Chris Smith, and with Eva Higginbotham. And for the rest of the programme this week, we're going to explore the science that is fermented foods.
Fermented foods are very much in vogue at the moment. Some are dubbing the sector a mega trend in the making. But biochemically speaking, fermentation is a metabolic process where microorganisms like yeast turn sugars in foods into alcohols and acids. That's how we make wine and beer, of course.
The same processes can produce delicious and nutritious foods as well. Lactic acid bacteria break down the sugars in milk, and that turns into cheese and yoghurt, for example. And sauerkraut, a tangy German side dish made from fermented cabbage, is also made by lactic acid bacteria. And Eva has been trying her hand at making some.
I love to cook, but I have never fermented anything myself before. And so sauerkraut, a relatively quick fermentation process that requires just 2 ingredients, cabbage and salt, seemed like a good place to start. So I lightly rinsed the outside of my cabbage to get off any dirt, chopped it up thinly, and then added some salt in a big bowl. Then I massaged the salt into the chopped cabbage. And after a few minutes of TLC, the cabbage became a bit limp and released a lot of water. I grabbed handfuls of my wet cabbage and loaded it into a clean jam jar before pouring over the remaining salty liquid in the bowl. Finally, I took the core of the cabbage and used it as a weight to hold the chopped cabbage under the salty, cabbagey brine before I covered the jar with a clean paper towel and rubber band to leave at room temperature to ferment. I'd been following a few different recipes that I found online, but being a naked scientist, I wanted to understand what the science was behind the different steps. So I called up University of Cambridge chemist Liliana Fruck. Liliana, I have some questions I'm hoping you can help me with. The first thing is that I had to wash everything that was going to be touching the cabbage really carefully. Why is that?
Because on every surface that we have and use, there are microorganisms living. And some of them might be really beneficial to the microorganisms involved in fermentation, and others could be having destructive action, which means that you need to wash as many of microorganisms out of your equipment so that the microorganisms that you use in fermentation come mainly from the cabbage leaves.
The first thing I had to do was chop the cabbage very thinly, and then I added salt to a big bowl. What does the salt do, and does it matter how much you add?
Salt is very beneficial for us, but if we take too much of it, we will ultimately die. And so it happens to microorganisms as well. So certain amount of salt will be damaging to the bad microorganisms, which you don't want to have in fermentation. But it will be tolerated by bacteria, which you need for fermentation of the cabbage. But the balance is very fine. So lactic acid bacteria, which you need for the cabbage fermentation, will tolerate up to 8% of salt per weight. which is good. But if you add a little bit more, you will kill it as well. So you will not get anything. So by carefully controlling the amount of the salt, you are promoting the health and the growth of fermentation bacteria, but you are removing the microorganisms that might cause it to rot, or they might cause some other effects which you don't want to have. So you are just allowing the salt to act as a kind of distinguisher between the bad and the good.
When I put the cabbage into the jar, I then had to pour the brine, so all the salty liquid that had come out of the cabbage, on top of the chopped up cabbage to make sure it was all covered. Why is it important to make sure the chopped up cabbage is covered in brine?
It's important because you are preventing the access of oxygen closer to the areas of fermentation. So fermentation will happen within the leaf and on the leaf of the cabbage. So you want to keep this area where fermentation is happening oxygen free and rich on salt. And so you need to make sure that you're covering the area of your cabbage so the oxygen from the air cannot get in.
The other thing is, from what I saw, I had to use a breathable cloth to cover the cabbage. I'm wondering why I should need to use a breathable cloth if we're trying to keep oxygen out.
In the process of fermentation, you might have different processes, chemical reactions happening. And in some of those reactions, you produce gases. And one of the gas is carbon dioxide. And you wouldn't like to accumulate the carbon dioxide in the large amount within the whole fermentation vessel, because carbon dioxide could dissolve a little bit in the liquid that you are having, and it could increase the acidity of the whole system. And then again, if you increase the acidity, this might be detrimental to some of the microorganisms.
What can I expect to see through the glass? Are there going to be any visual changes?
Yes, you might see that the liquid, which you might have noticed is existing, it becomes a little bit turbid. It's not as transparent. And you might see the change in the texture of the cabbage. If you see something black or brown, probably it's about the time to remove everything and throw it away. But as long as you just see slight color changes in terms of the liquid, or maybe changes in the texture of the leaf, that should be still okay.
And most importantly, what should I plan on eating it with?
Well, depends if you are looking for the vegetarian version or non-vegetarian version. But what I like the most is if you ferment your cabbage correctly, it can have such a wonderful flavor, and you can just add a little bit of garlic to it, maybe a tiny bit of pepper, and have a wonderful salad. I love it, particularly at this time of the year, to give me a boost of C vitamin as well.
Thanks to Liliana for talking me through that. I've actually got my jar here in the studio with me. It smells very strong, so hopefully that's a good sign. So stay tuned, because I'll be tucking into that later to find out how it tastes. Fingers crossed.
I noticed you said it smells strong. You didn't say it smells nice.
It's a very valid point. We'll see. It'll be a real life taste test coming up.
Well, we'll leave that point fermenting and find out how that goes later on. First of all, though, let's turn our attention to another delicious and popular food, especially with me, that's also made by fermentation, and that is cheese. Michael Tunick is a cheese scientist. Imagine being one of those. He's at Drexel University, and he's also the author of The Science of Cheese. So he has literally written the book on the subject. Hopefully he's going to be able to tell me why some of the cheese that I absolutely adore has the terrific flavour that he does. Michael, welcome to the programme. Tell us, if you wouldn't mind first, though, back to first base, how do we actually make cheese? What's the fermentation process here?
It starts by taking milk and adding bacteria to it, and that will start to digest the carbohydrates in the milk and produce lactic acid. That's the same thing that happens when milk goes sour, but the cheesemaker will stop it from getting that far, and will also add rennet, which is an enzyme which will break one particular kind of protein in the cheese, and that causes the milk to coagulate into curds and whey, the curds being the solid part. And then the cheesemaker will heat up the curd and cut it into cubes, and they work with it to squeeze out more whey. and then they'll press it and store it. And there's hundreds of different ways of doing this, and that's why you have hundreds and hundreds of different kinds of cheese in the world.
When you say they heat it up, do they heat it up enough that it actually destroys the microorganisms as well, or do they survive that process?
They'll survive that process. It doesn't get heated up much higher than 45 degrees C. So the microbes will survive, and they want them to, because they want them also to start attacking the fats and oils in the cheese, because they produce a lot of flavor compounds. And also you still get them attacking the protein, and so you get flavor compounds out of that too. And the carbohydrates will produce some also.
So the maturation process, when the cheese is left a time to mature, that's when all those complex and tasty flavours are developing because of the ongoing action of the microorganisms. It doesn't stop once they've just made a basic cube of cheese.
That's correct. And it depends on how they store it, whether you have it left unwrapped or whether they put wrapping over it or if they put wax on it. And then you have the temperature and the humidity to take into account. And of course, how long you have it stored. So some cheeses can be stored for just a couple of days, but you have Parmesan, which can be stored for a few years before they send it out.
I'm glad you brought this storage question up, because I've actually got sitting in front of me here, I've brought my cheese platter along with me, and I have sitting on it some cheddar, of course named after Cheddar, the place in the UK where cheddar cheese is said to have originated. But there are caves there. And one of the other cheeses I've got in front of me says it was cave matured at Wookey Hole. And I thought this was just sales speak. Yeah. But is that actually genuine science there then, that actually those caves do contribute to the cheese flavour?
Yes, because you have yeast, but especially molds in caves. And so they can settle on the surface of the cheese and start eating the cheese and producing these compounds. So that's where you get things like Roquefort, that has to be stored in the caves in Roquefort, France, or otherwise you can't call it Roquefort cheese. And there's other, caves around that are used for the same purpose. It's a good constant temperature, constant humidity place. You don't have to go build a building to do that.
I'm, as I say, happy to have in front of me my cheese board. So maybe you could actually talk me through some of what's on here and why it is the way that it is. Because I have a piece of cheddar, as I mentioned. Now, this is quite a hard cheese with quite strong, sharp flavours. I've got some Black Bomber here as well, which is one of my favourites. And sitting next to it, I thought we'd go for something local, totally different, some Cambozola, which is a blue cheese. And I've also got some, because we've got to keep the French people happy, some Port Salut. Now, they're very different textures. Yeah. The blue cheese and the Port Salut are quite rubbery in texture. Why are they rubbery and the cheddar's quite hard?
Depends on the protein breakdown. That the cheddar is allowed to age for a while, so the matrix of protein in there gets to be broken down a bit. So, and you also lose a lot of moisture. So the cheese is going to wind up being kind of hard and crumbly. The others, they try to keep more moisture in there. So that's going to be softer. And just the way they make it will be a bit more rubbery in texture than the cheddar will be. So Parmesan doesn't have much moisture at all. So that's one that you can grind up. But you have others where they're really soft, some goat cheeses, which are really smeary. So texture is a lot to do with how people enjoy cheese too, not just the aroma and the flavor.
And I've brought up a blue cheese. Cambozola is a blue cheese. How do they actually get the blueness in there? And where does the blueness come from? Why does that not happen naturally anyway?
The blueness comes from the mold powder that they add to it. It used to be that they would have the cheese sitting in the cave and allow the mold to settle on it, as I just mentioned. But nowadays, they'll take mold powder and they'll mix it in with the milk while the cheese is being made. So you have mold scattered around the inside of the cheese. And while the cheese is aging, they'll also skewer it. They'll pierce it to allow oxygen in to allow the mold to grow. Depends on what kind of mold you have. The cheese that you have is going to be kind of blue. You have other molds which are going to make kind of green veins in there. The Cambozola is made kind of like with Camembert, with this yeast mold mixture applied to the outside, but you also have this mold on the inside, which is like Gorgonzola. So that's the combination. That's where you get the name.
One quick question I've been dying to ask you, which is there is this claim that blue cheese before bedtime translates into funny dreams. Is there actually any truth in that, or is that just one of those stories that improves with the telling?
That's one of those stories that improves with the telling. I don't see anything out there which shows that cheese affects the way you sleep. So it affects your nutrition in a good way, but I don't think it affects your sleep.
I'm very pleased to hear that. And in the last 20 seconds or so, I've shared my 3 favourites. What are yours?
It's kind of like asking me which children are my favorite. But anyway, it's any cheese that has a good flavor to it and a good aroma and so forth. So right now, this minute, my favorite is a Manchego that I picked up at the supermarket a couple days ago. My wife and I just finished that off immediately. But it'll vary from 1 week to the next, whatever I encounter that tastes good.
Food for thought there then from you, Michael. That's Michael Tunick
Yeah.
from Drexel University.
This week, we're looking at the science of fermented foods, and shortly we'll hear if fermented foods really are healthier for you, or is it all a tasty myth? And I'll be getting my teeth into the sauerkraut I made earlier this week.
But first, moulds, like those that we use to make blue cheese, are a form of fungus, as are the yeasts that are used to make wine and beer. But it turns out fermented fungus can impart more than just a tasty extra flavour to foods like cheese. Quorn, the vegan-friendly meat alternative, is a fermented food too, and it's made from a filamentous fungus. And Paul Dyer from the University of Nottingham is a fungal biologist and also an expert on single-cell protein, which is the stuff that quorn's made from. What fungus do they use, Paul, to make things like quorn?
To give it its Latin name, Chris, it's called Fusarium venenatum. And as you said, importantly, it's a filamentous fungus, which means it grows by producing microscopic tube-like threads called hyphae, which help give it its meat-like texture as these resemble the muscle fibres. And interestingly, the group of Fusarium as a whole are perhaps better known for causing some serious plant diseases. But fortunately, this particular Fusarium species is non-harmful and instead is very good to eat.
How did it get discovered? Did somebody actually set out to find a particular filamentous fungus that would have the characteristic of meat in terms of its texture, or was it an accident?
It goes back to the late 1960s when there was thought to be a looming crisis with a worldwide shortage of protein, and a company, Rank Hovis McDougall, made a worldwide search of microbes that could convert starches, which was plentiful at the time, to protein. And that involved collecting over 3,000 fungi from all around the world and testing them for suitability for protein production and safety in industrial fermentation. And a funny story was that although they looked all over the world for these, the best fungus they found came from the garden compost heap of one of the research scientists just a few miles away from their own doorstep, and that was in Marlow, Buckinghamshire. So it was right on their doorstep all along.
So when you're eating things like quorn, you are actually eating someone's compost heap. Almost.
Part of it, the nice part, yes.
But what's involved in the process then of turning that fungus, which is a microorganism, into something that does resemble meat? How do you go from A to B?
Well, there's really, I think, 3 stages. First of all, you need to grow the fungus, and the Fusarium is grown in some of the world's largest industrial fermenters. And these are loop-shaped fermenters about 50 meters tall, containing about 160,000 liters of growth medium, which has got all the sugars and nutrients necessary for fungal growth. And the fungus is effectively pumped around them by jets of air. And so within the fermenter, the fungus is constantly growing. Secondly, you then need to harvest the fungus. So once the growth in fermenters reached a certain growth state, some of the fungal material is siphoned off to make corn. And the production process is designed so that as the fungus is removed, more fungi is growing in the fermenter to replace that that's removed.
How do you stop it getting... Oh, sorry, I thought you'd finished. I was going to just jump in and say, how do you make sure it doesn't get contaminated? How do you make sure that it's purely just the nice fungus in there and you don't get other stuff going in which could sort of hijack the process and poison people?
Yeah, because that's always a problem with fermentation. So in the case of corn, it does use a sterilized fermenter, and also all the nutrients and airflow that you're adding to it are also sterilized. So it's only the pure filamentous fungus that's growing in there.
And you were going to go on to say the final process is presumably turning the fungus you tap off into something sort of meat-like.
That's it precisely. So once the fungal hyphae has been harvested, that then undergoes various processing stages, such as there's a little bit of egg protein added in the vegetarian version or some alternatives in the vegan one. And that helps you form a matrix which has got this characteristic meat-like fibres. And then there's also various flavourings and colourings that are added to get, be it corn mince or nugget, whatever your favourite corn might be.
Is it nutritionally good for us to eat this stuff? Do you get all the stuff you need from it that you should get from meat?
Yeah, it's basically a relatively high protein, so it's got similar protein to white meat. It's got all the essential amino acids. Particularly beneficial, though, is it's got high fibre content and low fat content. So it really is a good sort of meat substitute.
Yes, indeed. A high fibre intake is good for your bowel health, isn't it? But talking of health, it's important to consider beyond just the health of the consumer, because there is also the environment here as well. How does corn as a meat substitute compare in terms of its environmental footprint with equivalent meat production?
Yeah, so I think it can be argued that corn has got several significant environmental benefits relative to traditional meat consumption. For instance, some work has been undertaken by the Carbon Trust, which, when it looked at greenhouse gas emissions, found that it was only about 10% of that of beef production and 25% of it for chicken. And also, given the current problems with global freshwater and land shortages, it also only uses about 10% of the levels of beef and half that of poultry. So as well as the health benefits, it does have these environmental benefits as well.
Can we feed the fungus on stuff that we would traditionally regard as a waste product? Are they not fussy eaters in the sense that we could actually take things we would throw away and then use those as the feedstock to produce the corn?
Very good question. I think you've been reading our recent research grants.
Well, actually, I haven't, but tell me more.
So traditionally, the fungus is grown on quite pure glucose and various other nutrients that have to be supplied to it. But there are some ongoing studies, of which I'm partly involved in, seeing if we can grow it on alternative sugar sources, such as sugars produced from the breakdown of straw and various other plant material that would otherwise go to waste. So that's definitely one of the moves looking forward into the future of corn production.
Well, I was wondering if you could team up with Michael, and all the whey, which is full of sugar from the cheese industry that they chuck away, could come your way.
That's a very interesting idea. I'm also involved in some cheese products as well, and I know that there's a lot of interest in trying to use that whey. I don't think we've actually tried feeding corn on those particular sugars, so a very nice idea, Chris.
Thanks. Well, if you make a fortune, you know who to remember in your will, Paul. That's Paul Dyer, formerly a research scientist, now a multimillionaire from the University of Nottingham.
Tasty stuff. And finally, fermentation produces lots of delicious food, as we've been hearing about. But how do fermented foods measure up when it comes to our health, as we've just been hearing? John Leach is a PhD student at University College Cork, where he studies the health impacts of fermented foods. So, John, what's the answer? Are they good for us?
It's a tough question to answer, I guess. It's early days for a lot of this research, but there are quite a few foods that are emerging as good for our health. There's about 5,000 different types from around the world. And the ones I think we're focusing on mostly at the moment, the ones that will contain live microorganisms, live bacteria and yeast at the point you're eating. So at the moment, I guess, yes, it's looking good for a lot of them.
That's a good point, isn't it? Because there are some foods that are made by fermentation, like we've been hearing, the cheese or the corn. And there are other foods, like my sauerkraut sitting gently on the table across from me, that are made in such a way that they still contain the microbes, the lactic acid bacteria that went into them in order, when I consume it, I'll be consuming that bacteria. What kind of benefits might we get from eating those sorts of microbes? Do we know?
Not entirely yet, no. The microbiome itself which in human terms is the collection of microorganisms that live on or within our body. That's very important for human health. And these fermented foods that contain these live microorganisms could potentially be a great source of some diversity into our gut, which is a good thing for health. There's a little bit of early evidence so far showing that fermented foods are potentially a source of this, but the research is really yet to tease that apart.
So the idea there would be that we've eaten some good bacteria, that goes into our gut and helps populate it with more good bacteria. What sort of studies can you do to try and understand this?
Well, it is difficult to study, but giving people these live fermented foods will be the first step. But there are problems with that too, because with any of these fermented foods, particularly the spontaneous ones such as sauerkraut, spontaneous meaning you don't add any bacteria or yeast to it to get it started. It's all there in the cabbage or the environment already. So unfortunately, this changes quite often from batch to batch. So it's very difficult to have a controlled scientific experiment when you're given a population the same thing again and again.
And that's about the guts, but is there any evidence of the benefits or potential benefits of fermented foods for other parts of our body?
Yeah, so the gut microbiome seems to have a large role to play in health all over the body. So there is evidence showing that consumption of fermented foods can be good for other things outside of the gut, such as mental health, for muscle soreness after training, so as a way for athletes to recover after intense training sessions. But again, there's only a handful of foods like milk, kefir, sauerkraut and kimchi that have really been looked into in detail, and that's 3 foods out of the potentially 5,000 that are out there.
What sort of link might there be between eating sauerkraut or kimchi and feeling better in terms of your mental health? Is it just eat more vegetables, feel better?
It could be, and that's another reason why it can be hard to study these foods. You have to find the right controls, the right things to compare them to. Sauerkraut and kimchi, I'm not aware of them being studied for health yet. It's mostly fermented milk, yogurts and kefir, and there is good evidence for kefir for improving the symptoms of some depressive illnesses.
When we think about yogurt and we think about kefir and these things, is this because they act similarly to the probiotics you might buy in the grocery? I'm thinking of things like Yakult. Are they sort of similar cultures that might be good for us?
Yeah, there will be quite a lot of overlap between the type of bacteria that are used for probiotics. In fact, some of them are sourced from fermented foods. A probiotic is a very specific strain, like a specific breed of a dog. So when you make milk kefir, you make it at home, you might not know what's in it. So it's really difficult to say for sure if the particular kefir you're drinking is going to have those benefits or not.
And I know that you like to ferment some of your own stuff. Tell me about what you've fermented, if it's good for you, while I get my sauerkraut ready for my taste test.
I'm looking forward to trying the sauerkraut. So I make a lot of sauerkraut. I've made kimchi. I make milk kefir every day. Kombucha is another good one. I love the taste of kombucha. I've tried a lot tepache, which is a fermented drink from Mexico. You just use the rinds of pineapples after you've eaten the fruit inside. I've made fermented salsa. It's a big list. I've been making these now for 4 years, so I've dipped my toes into quite a few different foods.
All right, it's time. Pray for me. I hope I'm not about to poison myself. Here we go. Okay. It's tangy. It's very crunchy. It still tastes very salty. It doesn't taste like what I'd expect cabbage to taste like. Does that sound normal?
Yeah, the salt's definitely that won't go away. It should be crunchy, it should stay crunchy. If it doesn't, I wouldn't eat it. And the sourness, it will get sourer and sourer the longer you leave it, but the fact that it's sour now, that's a good sign too.
That's excellent. Maybe I need to do what Liliana said and mix in some garlic and some pepper. What do you normally eat it with?
I would eat it with burgers or with hot dogs, salads. I went through a phase of putting it with absolutely everything because I had so much of it. But then I got a bit fed up with it. So yeah, mostly burgers and hot dogs.
All right, thank you very much. I'm quite pleased with myself. I have confidence now. I'll go ferment some more stuff. That was John Leach from University College Cork. So fermentation has a lot of benefits. It makes food more delicious and often more nutritious. And it has some bonuses for the planet and sustainability too. And if you're feeling like something tangy, you could try and ferment something of your very own.
I shall stick to my cheese board, though, Eva. I've been tucking in while you're having your sauerkraut. Let's finish up this week with our question of the week and an answer to Jeffrey's cool question.
We've had a cold and snowy winter, and I've had to shovel my driveway every few days. Today, we had a fly in our house, and I was curious if it survived the cold somehow or recently hatched.
We've all been there. It's been a cold winter and everything seems dead outside, and then you stomp inside and there's already a fly buzzing around, enjoying having a nice warm room and a human to annoy. Where do they come from? Well, Erica McAllister from the Natural History Museum in London has some thoughts on the origins of the buzzing suspect.
First off, to comment properly on the specifics of your fly, I would really need to see it to identify it.
Ah, not so easy to pin down then.
However, there are 4 scenarios for your hardy beast.
Oh good. So what's the first option, Erica?
Number 1. It is an overwintering species that has come out early. Many flies overwinter as adults. Some really hairy beasts include the cluster flies. They do exactly that. But there are others that will take a warm place and hunker down, including many female mosquitoes. The cluster flies will stay put for most of the winters, but many, including the mosquitoes, will take opportunities to feed when the conditions become favourable.
I also feed whenever conditions become favourable, so I can understand that, but some of these flies will be ones that are still growing.
Number 2. The majority of flies will be snuggled up and metamorphosizing in their pupal cases or pupariums. Flies are some of the earliest to emerge as adults in spring, and they may have been tricked into doing so by some environmental trigger, maybe it was your house, and so believing that conditions were now favourable. Number 3. There are those that are completely badass in that they do not regard the cold or the snowy conditions as an issue. I.e., in the Arctic, there's 4,000 species of insect, of which 2,000 are flies. This could be a cold-adapted species that you're seeing.
And of course, if a fly doesn't like the cold, there's one obvious refuge it might find.
Or number 4, these could be very anthrophilic, i.e. they love humans. And they can use our environments for their own nefarious deeds. We provide lots of heat, shelter and food for them to survive.
Thanks to Erica McAllister for flying in that answer. Next time, we're answering this burning question from Trent.
I just got back from walking my dog. Now, about a block from my house, there's a trailer that's been parked there for a year or two, and every time we walk by, the dog pees on the same tire. Got me thinking, urine contains uric acid. Is that strong enough to eat through the rubber of the tire? If so, how long would it take?
If you can help, come join the debate on our forum, nakedscientist.com/forum. Or if you'd like to ask us a question, we're on chris@thenakedscientist.com or use the web form at thenakedscientist.com/question.
And that's it for this week. Thanks to Eva, who fermented and distilled out a very tasty treat of a programme for us this week. And be sure to tune in next time because we're going to be discussing ADHD, or Attention Deficit Hyperactivity Disorder. 1 in 5 people are affected by this. It leads to difficulty with concentration and focusing on tasks, and many adults don't actually realise they've got it. So what is it? Is it becoming more common, or are we just better at detecting it? Moreover, what can we do to help people who've got it? The Naked Scientist comes to you from the University of Cambridge's Institute of Continuing Education. It's supported by Rolls-Royce. I'm Chris Smith. Thanks for listening, and until next time, goodbye.